The power consumption of a central processing unit, or CPU, depends on several factors. Firstly, the CPU model and its generation play a significant role. More powerful and modern CPU typically require more power. Secondly, the workload placed on the CPU greatly influences power consumption. CPU-intensive tasks such as video rendering or gaming draw considerably more power than when the CPU is idle or performing light tasks. Thirdly, overclocking, which is running the CPU at a higher clock speed than its specified rating, increases its power consumption. Typical power consumption ranges for desktop CPU vary based on their performance level. Low-end CPU generally consume between 30 and 60 watts. Mid-range CPU typically consume between 60 and 120 watts. High-end CPU can consume between 120 and 250 watts or even more. You can indeed use a clamp meter to measure the current drawn by your CPU, although it will measure the power consumption of the entire computer, not just the CPU in isolation. Here's how to do it. 1. Clamp the meter around the power cable. Connect the meter's clamp to the alternating current power cable that runs from the power outlet to the computer. 2. Set the meter to alternating current mode. Make sure the meter is set to measure alternating current in amps. 3. Read the display. The meter will show the current flowing through the power cable, representing the power used by the entire computer, including the CPU. Keep in mind that to measure the power used by the CPU alone, you would need to isolate its power draw, which is challenging to do without specialized equipment. Also, the power supply unit, or PSU, in your computer may not always operate at its maximum rated capacity. The total power consumption of all components in your computer, including the CPU, graphics processing unit, random access memory, and other devices, should be within the power supply's rated capacity for stable operation. Therefore, while the clamp meter gives a reading for the entire system, it provides valuable insights into how your CPU usage impacts overall power draw. To understand the power consumption more technically, it's important to delve into the factors that influence it. The CPU architecture, manufacturing process, and clock speed are key determinants. Modern CPU often incorporate power-saving technologies that dynamically adjust clock speeds and voltage based on the workload. This helps minimize power consumption when the CPU is not under heavy load. The CPU thermal design power, or TDP, is a metric that indicates the average amount of heat the CPU dissipates when running at its base clock speed under a typical workload. This value is often used as a guide for selecting appropriate cooling solutions. However, it's important to note that the actual power consumption can exceed the TDP during bursts of activity or when overclocking. Overclocking involves increasing the CPU clock speed beyond its specified rating, which can significantly boost performance. However, it also leads to increased power consumption and heat generation. Overclocking requires careful monitoring of temperatures and voltage levels to ensure stability and prevent damage to the CPU. Different CPU models and generations have varying power efficiency characteristics. Newer CPU are often designed with improved power efficiency, meaning they can deliver more performance per watt of power consumed. This is achieved through advancements in manufacturing processes, architectural improvements, and power management techniques. The workload is another critical factor influencing CPU power consumption. CPU-intensive tasks such as video encoding, 3D rendering, and gaming demand significant processing power, which results in higher power consumption. On the other hand, tasks like web browsing, word processing, and email typically require minimal CPU resources, leading to lower power consumption. The clamp meter provides a convenient way to measure the total current drawn by the computer, but it doesn't differentiate between the power used by the CPU and other components. To isolate the CPU power consumption, specialized equipment, such as a power meter or a motherboard with integrated power monitoring capabilities, would be required. These tools can provide more granular data on the power consumption of individual components. When using a clamp meter, it's essential to ensure that it is properly calibrated and used according to the manufacturer's instructions. Incorrect usage can lead to inaccurate readings or even damage to the meter. It's also important to be aware of the safety precautions when working with electrical equipment. Always disconnect the power cord before making any connections or adjustments to the meter. In addition to the CPU, other components in the computer also contribute to power consumption. The graphics processing unit, or GPU, is often one of the most power-hungry components, especially in gaming or video editing setups. Random access memory, storage devices, and peripherals also consume power, although typically less than the CPU and GPU. The power supply unit must be able to provide sufficient power to all of these components. The PSU wattage rating indicates the maximum power it can deliver. It's generally recommended to choose a PSU with a wattage rating that is higher than the total power consumption of all the components in the computer. This provides headroom for future upgrades and ensures stable operation. Power efficiency is another important consideration when selecting a PSU. Power-efficient PSU waste less energy as heat, which can save money on electricity bills and reduce the strain on the cooling system. PSU are often rated with an 80+ certification, which indicates the power efficiency at different load levels. Higher 80+ ratings, such as 80+ Gold or 80+ Platinum, signify greater power efficiency. Power management settings in the operating system can also help reduce overall power consumption. These settings allow you to adjust the computer's power usage based on your needs. For example, you can configure the computer to automatically enter sleep mode after a period of inactivity or to dim the display when idle. These measures can significantly reduce power consumption when the computer is not being actively used. Understanding the power consumption characteristics of your CPU and other computer components is essential for optimizing performance, ensuring stable operation, and minimizing energy costs. By using a clamp meter and monitoring power usage, you can gain valuable insights into how your computer is using energy and make informed decisions about hardware upgrades, power management settings, and cooling solutions.